All right, so good morning, everybody. Today we are going to be covering notes 1.2 line segments here. So you should have your packet open to page 11, where we're going to be working on the postulate idea here first. Now, in geometry, there's a lot of rules and theorems and ideas that people came up with that were eventually accepted as true. Now, there's certain things that needed to be proved or proven, and then there's other things that people just took as a fact. So, our first word here for today is the word postulate or an axiom. Okay. Now, basically, a postulate is a statement. So, it is a statement that is accepted as true. That is accepted as true, but here's the catch, it's accepted as being true without proof. The idea is it was so obvious to people, everybody believed it instantly. Nobody had to prove anything. For instance, here's a very classic postulate. One of the postulates that we know is if I give you 2 points, then the postulate that exists out there is that there is only one straight line that you can draw between them. And that's true. Look at that. There's only one line that I could actually draw between those 2 points. So that little rule that we just said, that between 2 points, there's exactly one line that can be drawn. Nobody needed proof of that. It was an obvious statement and automatically accepted as true. And so that's a kind of an example of a postulate. Now, a theorem, on the other hand, a theorem is a little bit different. Remember, here, everybody believed it instantly when they came up with it. But then when we talk about a theorem, well, this is also a statement made in math, and not just math, but in different fields. But it is a statement that is proven to be true. I know there's a lot of commonality there, but the idea is a postulate, everybody believed it instantly. In a theorem, people had their doubts, right? People said, yeah, I don't believe you. You got to prove it to me. So a theorem is something, an idea that somebody came up with, and then they proved it to be true. That's why the one very classic theorem that goes back to your middle school days was the Pythagorean theorem, where Pythagoras himself had to prove his idea that the two sides of a right triangle, the two legs, added together, given each a power of 2, of course, would give you the third side squared. This is the classic Pythagorean theorem from your middle school days, which we'll use again later on in this course. But that is one of the most classic and well known theorems that exist out there in math. Now, we have postulates. Again, everybody believed it to be true immediately. We have theorems. People didn't believe it, so you had to prove it to them. And so right now we're going to talk about some postulates here because as soon as people saw it, people automatically believed it because it made sense. And that has to do with what we call line segments, which is today's topic. Remember, a line segment like we have here doesn't go on forever and ever past the A or past the B going left and right. No, it stops. This is an end point. This is an end point. Now, when we name it, now this is what we practiced last week. This right here, we would name it segment A to B, or BA is also acceptable. Or we would use the symbol, right? A little line on top, no arrows, from A to B. On the other hand, if you look, we're basically saying we're cutting it off from here to here. This is the segment we're talking about. But if you notice, this segment actually has a measurement. So someone took their time to measure it. And they said, all right, from here to here, we're going to pretend that it's 6 inches long. Now, here's the catch. It's measured. If you're going to talk about the measure of this, we would say the distance, here we go, from A to B is 6 inches, right? Now, that's a lot to write on. That's too much writing. So we have a shortcut. When we want to tell someone in geometry in a faster way that the distance from A to B is 6, we would say from A to B, the distance from A to B is 6. There's a huge difference here, though. If you notice, we have left something out. Look at that. There's no line on top. When we don't have a line on top, that's when we're talking about distance between two letters, between 2 points, sorry. You put a line on top, you're just mentioning the segment in general. Give a distance, no line. You want to talk about the segment, then you write the little line on top. And then the last phrase that we have here says the word between. And yes, if something is in between, you say, oh, it's in the middle. That's usually what people will say. We have to be very careful with that. Between, right, does not officially mean, it does not officially mean the middle. It does not mean that. And that's the misconception that people have. They say, oh, it's between the two people. Oh, so I go to the middle? No. Right? It basically, here's the main idea. It must be on the line. It must be on the line. But not necessarily the middle. So when they say the word between, try not to put anything in the middle of anything else. So let me show you here, right? Let me give you an example. If I were to say that point C is between A and B. Remember, I'm using capital letters, which means I'm talking about points as well. In geometry, you don't have to literally say point. Capital letters are automatic points. So look at how I could draw this. C is between the A and the B. So that means it starts with A. It's going to end with B. But when they say the C is between, they never said the word middle. Remember, the letter C could be right here. It could be closer to the A. It could be closer to the B. But because they never said the word middle, you cannot place it there. Okay? And that's the biggest thing to be careful with today. All right. So now with that said, here comes the big idea of the day. All right. If you're going to leave class today knowing something, this is it coming up. The segment addition postulate. So that means, right, this is our big idea for today. But because it's a postulate, that means it was so obvious, nobody had to prove it. And the segment addition postulate is going to be right here. We'll address it later, but I just want to throw that out there right here. So we have to actually write a little phrase. It says, if B is between A and C, so if the B, there it is, look at that, there's the B between the A and the C. Well, notice I have this little segment right here. Give it some color. I've got this segment right here. I have BC. I have another little segment right there. But if I put these two segments together, right, side by side, well, we created a bigger segment, which means we would have created this bigger segment from here to here. Well, that's common sense. If I put two things together, well, of course I'm making something bigger. But that's what this postulate is. That's why everybody believed it instantly. If I take this little segment and then I take this other little segment, well, then it's making the big segment here in blue. And that's what this postulate is saying. If B is between A and C, then from A to B, and if I add it to segment B to C, then I will get the bigger segment from A to C. I get the big segment here. And that's what this rule is saying. Little plus little is equal to big, which is what they're trying to tell us in this postulate. Let me show you. If I tell you, let's bring in the same colors, in fact. So here's the big segment. Here are the two little ones again. Here's the BC. And here is, of course, AB. So check this out. If I were to tell you that this segment is 7, that pink, right? I measure it and it measures 7. And then I measure this green one and they tell me, oh, you know what? That's just 2. Well, the question is, if I put them together, then how much is this bigger segment? Well, obviously, this bigger segment here would measure, in this case, 9. Because little plus little is going to give me the big. That's today's only idea that we have, and it's today's big idea. Okay? So let's practice a little bit here. So in example number 1, it says, write an expression for the length of the segment. Okay? Now understand one thing. They didn't say you're going to solve. We're just going to set things up. So they said, this is what they want you to find. They want you to find from A all the way to C. Well, notice that's the big. They want you to find the big segment. But I have this little one right here, which is this. And I have this bigger, slightly bigger segment, but it's still one of the littles. And I have this one. Well, you know the rule of the day. Little plus little is equal to big. In fact, look, here we go. A little plus a little is equal to big. The little orange one says x plus 2. I am going to add, right? We have a big plus sign here, plus. Then it says we'll bring in the other little one. The other little one says 7x minus 3. And then the big segment, now I have no idea what that is. So we're just going to call it AC because that is what they asked for. They said, hey, tell me how to find the length of that segment A to C. All you have to do now is do a little bit of algebra. Remember, we combine like terms. So when I combine the x with the 7x, well, then that's 8x. And then when I combine the 2 with the negative 3, that becomes negative 1. We have now officially found a little formula on how to find AC. Obviously, we can't find it because I have no idea what x is, but that's what they were asking. They said, give us an expression. That means my answer is still going to have an x in it, most likely. Now, if you look at letter B, they said, hey, we want you to find QR. Well, let's go look at QR. If you notice, this is why highlighting and marking it up helps. QR is actually one of the littles. So I'm looking for a little one this time. Now, understand the rule doesn't change. It's still little plus little is equal to big. But then let's look at what else they gave us. They gave us this green one. Well, that's also a little piece. But then if you notice, they actually gave us the entire thing. Look at that. They gave us the entire thing. And because they gave us the big piece, we just have to learn to put things where they belong. So in this case, little plus little is equal to big. All right. The first little, well, you know what? Let's start with the one we don't know. So I'm just going to call it QR. Then it says put a plus sign. Well, I'm going to find the other little. Well, the other little says 8y plus 5. So I'm going to go 8y plus 5. There's the equal sign. And then it says on this side, put the big. Well, the big says 13y plus 25. That's why you need to highlight, mark things so that you know exactly where everything goes. Now, this one is a little bit different than the last one that we did. If you notice, the QR is not by itself like it was here. So I actually do need to move a couple things over. First of all, I'm going to get rid of this 8y. I'm going to move it over to the other side. And so notice what I'm left with here. I'm going to be left with 5y. But there was someone else that I needed to get rid of. And the other one I need to get rid of in this problem was this plus 5. Well, then I'm going to take away 5. from both sides. Remember, whatever you do to one side, you do to the other. And 25 minus 5 is simply 20. Leaving me with the only thing left out here was the little that I was trying to find an equation for. And we have, remember, they wanted me to create an expression for it, and we simplify a little bit, but there's our result. That's us just continuing to use the concept of little plus little is equal to big. Now, some of these problems aren't going to be this difficult. Sometimes you're just going to have numbers that are easy enough to do. In fact, once you're caught up writing this note, flip the page so that we can finish the notes here for the rest of the day. All right, so here we go. So our last page in our notes. By the way, this is your classwork. Look, a lot of little plus little is equal to big. That's what you're going to try out for today. Okay, so here we go. Now we're going to draw something on our own because we don't have anything yet. So I'm going to look here, and there's the magic word between. Remember, that doesn't mean middle. Y is between the X and the Z, so that means it starts with X. It ends with Z, so I'm going to connect these two here. Remember, every capital letter is a point, so you have to draw them. And then they said the Y is somewhere in between. All right, well, you know what? I'm just going to put it right here. Doesn't matter where you put it, but try to stay away from the middle. All right, so I did the first part. Now I'm going to read one thing at a time. The first thing it says is from X to Y, you're going to put a 7. So from here to here, I'm going to put a 7. And then it says XZ. All right, well, let's see. From X to Z, I'm going to put a 20. Now be careful. I can't highlight here. You see, I already have a green one there. X to Z is actually from here all the way to here. So I don't want to put that number 20 right there. That would be wrong. The number 20 is the big. And then finally they said, find me the length of YZ and explain. All right, so they want me to find this one. That's the question they're asking. Well, look, this is why we label. This is why we write things out in this class. When you're working with this problem, the first thing that I notice, this is a little. This is a little. Now I'm looking for it, so I have no idea what it is. And then this is the big. Now, if I have no idea what it is, instead of a question mark, I could just put an X so I can solve for something. It's just a little weird because we already have an X there, so it gets a little strange. But anyways, little plus little is equal to big. Now I'm just going to put everything where it belongs. The first little is 7. Now the other little technically is called YZ. So you know what? I'm gonna use that because we already kind of have an X in the picture. I don't want to bring another one in. And then the big is 20. All right. Well, look, all it takes is one step on this one. Subtract the 7 from both sides. And just like that, we're pretty much done. From Y to Z, the little right there, from Y to Z is simply 13. And when they say, give me an explanation, remember, the only explanation I have to give is that we did this because of the segment addition postulate. I mean, it's even at the top there. This is your reason for every single one of these problems. Because people know this postulate, right? Mathematicians know this postulate. You tell them that, they know exactly how you got this answer. And again, things can get a little bit tougher as you work them out. So we'll just do one more for the notes here, especially because of the time on a Monday. Suppose that A is between J and M. A, 3 capital letters. That means 3 points on my picture. There's a J. There's the M. So let me connect these dots here. They said the A is somewhere between them. All right, look, I could put it over here if I wanted to. Notice how I stayed away from the middle. All right, I have a picture. So now let's look at it carefully. They said from J to A. All right, I could highlight it here. It's not the big. Is 3x plus 2. All right, so I'll put a 3x plus 2. Then it says from A to M. All right, let's see, A to M. That's a little. I could highlight right here. because it's a little, is 5x plus 1. So I'll put a 5x plus 1. And finally, they said from J to M, whoop, same color there, let's switch it up. From J to M, let's see, you see, that's the big. So you can't write it in here. The big is 27. So I'm going to put a 27 right here. But again, the rule doesn't change. We have two littles right next to each other, and they made this big here. So little plus little is equal to big. All right, here we go. Look. I know it doesn't look too mathematical when we say little plus little is equal to big, but that's what the postulate is. So here we go. Let's check it out. The first little is 3x plus 2. The second little is 5x plus 1. The big is 27. Now notice, we did this earlier, but this time they did say solve for x. All right, well, here we go. These are the kind of problems that we had last week. Combine like terms first. So the 3x with the 5x, well, then that's 8x. The 2 with the 1, well, then that's a positive 3, and it equals 27. All right, so I keep it going. Subtract the 3 from both sides. Remember, we're just doing basic algebra solving here. 8x is equal to 24. And finally, our very last step is to divide by 8. So my answer is x is equal to 3. And so just like that, we have found the answer that they asked for, solve for x. Now they did say explain. How did we know to use this method, right? Well, we looked at our picture. So my explanation is that we applied the segment addition postulate. That's the great thing about math, especially with postulates, since everybody knows them in the math community, of course. Then that's all the explanation we need to give. All right? Now, we're going to save number 3 for when I do come back on Tuesday with you. But for now, that's the end of your notes there. You only have one assignment to work on for today, and you're going to work on it in class. And if you don't finish it, you'll finish it for homework. And that's to do classwork 1.2, numbers 1 through 10. So no big ideas again. We'll take another day without it. But this is the assignment you need to work on. You're going to practice plotting your points and connecting. Look, it only says connect from A to B and measure it, write down what the distance is, and then connect the C and the D only. If you end up with a box, then you did this wrong. Look at what it tells you. Only connect the A and the B, only connect the C and the D. And then you'll be able to tell me if they match up or not. That's what congruent means. Are they exactly the same size? All right. And then you get a lot of these. Now, there's 10 questions. There's a backside, so just be ready for that. But besides that, have a wonderful day, and I'll see you tomorrow.